All right. So the last section we did was 1.7, which was titled Exponents and Laws. I mean, not laws, exponents and order of operations. Today's section is going to be 1.8, Intro to Variables and Algebraic Expressions and Equations. The intro. So the first things about this lecture is going to be some definitions. Let me go ahead and get a highlighter. So if you look at the first definition, variable, it's pretty much an unknown value that's represented by a letter. So X, Y, Z, A, B, any letter can be used to describe a variable. The next definition we have is an algebraic expression. So last class, we did regular expressions. So regular expressions or just an expression itself is just numbers that have a combination of different operations. So like plus, minus, division, multiplication. Algebraic expression, the difference from a regular expression to algebraic expression, now there's variables involved, letters and numbers. And we're going to be seeing that today in today's lecture. Now take a look at this note. Now, a note is when your professor in math is trying to tell you like, hey, this is an important fact that we need to remember as we move forward in the class and in your mathematical career, guys. When I say mathematical career, some of you guys are going to become engineers. Some of you guys are going to become nurses or medical, like doctors. Some of you guys are going to become accountants. Some of you guys are going to become teachers or whatever the hell you want to do it is you want to do. You're all going to have math, right? And maybe one math class and maybe up to calculus 3. But this course is to build your foundational. It's building off of what you were supposed to learn in high school and pretty much fixing all the gaps that you missed out on, because public education isn't perfect. So no, if a number and letter or two letters are next to each other, we can assume they're being multiplied. That is the pretty much the two letters. So 4x. So 4x is the same thing as 4 times x, or 4 parentheses x. So when you see 4x by itself, I need y'all to understand that the implication is they're being multiplied. Now xy, those are two variables as well. They're next to each other. Guess what? They are being multiplied. Now, there's two ways to define multiplication in college. We have this little dot to show multiplication, and then also parentheses, guys. I do want to go away with the different type of multiplication. It is very important to understand that we don't do the old school. Remember in elementary, middle school, we had this 2 times 3, the little x for the time. This is going to go away. Why are we going to go away with that? Do y'all guys think? Why are we no longer? Go ahead.
I guess in typical, excuse me, in typical jobs, like you said, engineering, medical, or like I mentioned in the chat with entrance exams in 4 years, they're not going to use that, I imagine.
No, they're not. They're not. And it can also cause confusion. It also looks like what letter?
Yeah, that's how I've been so confused with this stuff for years. So you're right on that.
Yeah, it can confuse people as a variable, but we don't want that confusion anymore. So we're going to go ahead and move on to this format now. Does anyone need more time on this slide before I move forward, guys? Anyone need more time?
Yeah, just like I'd
One
say
more.
4 minutes.
I'm gonna give you about 2 more minutes, guys. Now, if I have any new late students that are logging on late, or if I have anyone that's a slow writer, feel free to take pictures or screenshots of every slide so that way you can have it on your collection. After today's class, I will start emailing you guys the blank lecture notes and also the filled out lectures as well. All right. That was additional time, guys. I am going to be moving on because we do have a lot to cover this week. All right. Example one, guys. I'm going to go ahead and give you about a minute just to write this first part here where it says example one. So it says evaluate x plus 6 if x is 8. Evaluate x plus 6 if x is 8. So the expression that's in the problem, guys, would y'all say it's a regular expression or an algebraic expression? What do you guys think?
I have to say algebraic because it's asking us to evaluate if X is 8.
Ah, that's good. Justin, you're correct. It is an algebraic expression, but your justification may not have been too correct. You want to say it's an
Yeah,
algebraic expression because it has letters and numbers.
that makes more sense.
All right. That was a 1 minute timer, guys. I'm gonna go ahead and get started. So the problem wants us to tell us, they're giving us an expression that says x plus 6, but they're giving us a different parameter. They want us to find out what x plus 6 is when x is 8. So what we're gonna do now is wherever we have the x value, I'm gonna go ahead and replace it with 8. So then we get 8 plus 6. Now remember, just because you're in college does not mean that you have to do mental math, do this in your head. If you have a calculator, go ahead and do 8 plus 6. I know how to do that in my head. So 8 plus 6 is 14, and we are done. What questions do we have on evaluating expressions when they give us values? Any questions so far?
So typically, will it actually give you the number when you try to find out what's X? If that makes
Well,
sense.
so this isn't an equation, Justin, it's an
Okay.
expression. So what they want us to
Ah,
do is, hey, because if it had an equation, it would have an equal sign, but there's no equal sign. It's just x plus 6. So they want us to say, hey, what is x plus 6, guys, if x was 8? What can you tell me? And then you have to plug it in and do the math. Now, I want you to try out practice one, everyone. I'm going to give you a 1 minute and 30 seconds to do practice one. Or I'm going to give you a minute 15. Ready? Go. So write it down and work it out. Now take a look at this note. Don't write this note until you finish practice one, all right? But it is very important for you to write that down. Now, I want to keep this lecture class very interactive. So if y'all can say your answer in the chat, hey, I got whatever for practice one or for the problem. And students, and when one person puts their answer in the chat, if you can please say you agree with the answer or you disagree. If you disagree, put the answer that you got. So that way we can have a debate and discuss, okay, which was the correct method or which one was the correct solution. Got about 20 seconds left, guys. Let's see what we got. All right, so Justin shared that he got 5 for practice one. Does anyone agree or disagree with Justin?
I agree.
I agree.
Agree. Excellent, excellent, guys. Because pretty much what he did was plugged in the value for 7 for x, right? So he did 7 minus 2 and did that operation and got 5, make sure you box your final answer, and we are done. You're correct, Justin. Good job. Now, if you did not get 5, guys, please look at the steps that we did. If you have any questions, please unmute and ask or type it in the chat. Now, remember the note. I'm gonna read this note out loud. Note, x is 5 can also be written as x equals 5. So this note highlights how mathematics can be actually written out as words. That x is 5 is the same thing as x equals 5. All right, guys, let's move on. Example 2. It gets a little more interesting, right? Now the expression gets a little more complex. I'm going to give you that 1 minute to write this problem down in your notebook, and then I'll go ahead. Remember, every example I'm going to work out. Every practice problem, you're going to work out.
Do we do the example or the practice?
So if you're confident enough in your skill set to do the example on your own with how I explained the other example, you can get started. I actually am I am into you guys doing it yourself. And then you can always check how I did it. Now, let's say you're not confident in your skill set about this problem, then you would start it and then stop where you can't go anymore and then see me work out the example. Make sense? All right, about 10 seconds left before I go ahead and start working it out. So you're going to evaluate 2 parentheses x minus y for x equals 6 and y equals 3. So what does that mean, right? So now we have an expression that has 2 different variables. They're telling us that x is 6 and they're telling us that y is equal to 3. So when you see the word evaluate, guys, that's telling us that we're gonna get a value at the end of the work. We're gonna get a number for the answer. So let's go ahead and replace the x and y. So 2 parentheses, instead of x, I'm gonna write the number 6 minus, instead of y, I'm gonna write the number 3 parentheses. Now we have to simplify this using PEMDAS. Remember what we did last class in PEMDAS? All right, P stands for parentheses. So I'm gonna go ahead and simplify the parentheses. So 6 take away 3 is 3. So 2 parentheses 3. There's no exponents, and now we're gonna multiply. Remember, parentheses implies multiplication. 2 times 3 is 6, and we are done. So far, not bad, right? I'm gonna go ahead and give you guys 1 minute and 15 seconds for practice 2. Good luck. Now, if you have any questions on example 2, please feel free to unmute and ask, and I can reset the timer for the practice problem. Remember, feel free to put in your answer for practice 2 on the chat once you're done. Or unmute yourself and say what you got.
I got 20.
Yeah,
20?
I got 20.
20? So 20 is a potential answer, guys. Does anyone agree or disagree with 20?
I
A lot of
agree.
people are agreeing. Good, good, good. Okay, cool. And let me see them do the mental math real quick for yeah. Yeah, it's correct. Anyone have any questions or would like me to work out practice 2 before we move on?
So since you mentioned earlier that we were applying PEMDAS, so throughout this whole chapter, a lot of this we could reapply PEMDAS, what we talked about last week then.
And that, Justin, you just highlighted an important concept of mathematics, that it is a building block upon another, that
Good
every
old precedence.
yes, it's all interconnected, guys. Cool. So does anyone need me to work out practice 2 before we move on, or is everyone okay with 20? All right, I'm gonna go ahead and move on, guys. Feel free to let me know if you want me to work any problems out. I do not mind. Here's example 3. As you see here, that the examples are getting a little more complex, right? Nothing in life comes easy. So let's go ahead and give you a minute to copy this problem down before I go ahead and work it out. We're in example 3 now. So now this expression is a fraction, guys. But remember, last class, I did go over some examples on how to simplify fractions, right? We do the top by itself and then the bottom, and then we divide both. So let's go ahead and get started. So example, we evaluate x for when x is equal to 35 and y, x minus 5y over y when y is 5. Now we're gonna go ahead and plug these in. So as for x, we got 35 minus 5 parentheses 5 over 5. So the bottom is already kind of simplified for us, right? We just had to mess with the top. So for the top, are we gonna do, so remember PEMDAS, right? Am I gonna go ahead and subtract 35, take away 5? Or am I gonna do 5 times 5 first?
5 times 5.
Excellent. And then we get 5 times 5, so it's 25. So then we get 35 minus 25 over 5. Since we multiplied already, we just got to do what on the top? Subtract, right? 35 take away 25 is 10. We got 10 over 5. Does 10 over 5 simplify to a whole number, guys? It does, right? It gives us 2. And we're done. What questions do we have on example 3, class? Any questions? All right, I'm gonna go ahead and give you guys about a minute and 15 seconds to complete practice 3. Good luck. Don't forget to put your answers in the chat to see if other students got what you got, and if you see an answer, you can agree to that answer. Well, Justin, that's not simplified, sir. You have to simplify that final answer.
At 4.
Jacob, we got Jacob's claim is a 4. Does anyone agree? Jose Gabriel agrees with Jacob. Any other people agree, disagree with 4? Justin, agree. Felicia agrees. Thank you. Justin, what did you get when you simplified 24 over 6? Thank
So
you.
that's it.
Got 4.
4 over 6 is what equals to 4.
There you go, sir.
Okay.
Okay, so we don't want to stop here. If this can be simplified, always go to the next step, okay? Which becomes 4. Good job, class. That is correct. All right, let's keep going. Example 4, give you a minute to copy this question down. as you notice, the examples get, the expressions get a little more complex, right? But don't be intimidated because the x squared plus z minus 3, we don't know what to do with that, right? But once we plug in the values, x and z, we then it becomes an expression like we did last class with orders of operations. The letters disappear is what I'm saying, or highlighting. All right. Let's take a look at example 4 class. So the expression says x squared plus z minus 3, right? Here we have x is 5 and we have z is 4. So I'm gonna go ahead and plug those values in. So then we're gonna get 5 squared plus 4 minus 3. Now this is something we can get done on our own. We know how to simplify expressions, right? Using PEMDAS. So let me write out our checklist, right? No parentheses for me to do, so we're done there. Exponents, yeah. Can someone tell me what 5 squared is? 25, that's correct. And then bring down everything else. And then there's nothing to multiply or divide. So we add and subtract from left to right. So 25 plus 4 is 29. 29 minus 3 is 26. And we are done. Any questions on what I did in example 4 class? Any questions whatsoever?
No.
All right, go ahead and get on practice 4 then. I'm gonna give you a 1 minute because you guys are getting pretty fast, pretty quick with this. So 1 minute to do practice 4. Good luck. I will add more time if y'all need it.
I got 18.
18, let me put that down. We have a possible 18, guys. Does anyone agree or disagree with the 18? I couldn't get to see who said it, but 18.
Agree.
Agree. We have another agree. Marlith agrees. I'm glad
I
you
agree.
agree. Okay, a lot of people are agreeing. Let me see. Let me do this in my head real quick. What is it? 17. Oh, okay. Yeah, it is. The answer is 18, class. Does anyone need me to work out this practice problem at all? Anyone have any questions or need me to, sir, can you work this out? I couldn't get it. I got this instead of 18. Any questions at all? Speak now or forever hold your truth.
Can you go over this one?
Yes, I can, Sophia. Thank you for speaking up, ma'am. All right. So let's look at the expression. So we have 25, right? 25 minus z cubed for when z is 2, and then want us to find out plus x when x is 1. So we have the expression here, right? So I'm not going to go ahead. I'm not going to rewrite it because it's already there. So I'm going to plug it in now. So it'll be 25 minus 2 cubed plus 1. And we have to follow using PEMDAS. Do not forget. No parentheses, right? But we do have 2 cubed. Sophia, for 2 cubed, that's repeated multiplication, right? How many 2's are we going to multiply for 2 cubed, Sophia?
3.
Yeah, 3 2's, right? So it'll be 2 times 2. I'm going to do it over here. 2 times 2 times 2. 2 times 2 is 4 times 2 is 8, right? So this becomes 8. So I'm going to replace it with 8, but bring down everything else. Notice how nothing else changed in the expression. 25 is still there, the minus is still there, plus and the 1 is still there. Just the 8 is there now. So now we're done with exponents. There's no parentheses. We're now going to move to multiply, divide, and add and subtract. We're going to add and subtract from left to right. 25 minus 8 is 17. Bring down the +1, which is just 18, and we are done. Does that make better sense, Sophia?
Yes, sir. Thank you.
No, anytime. All right, let's go ahead and move on. Now, example 5, guys, is a word problem. I just wanted to throw one out there just because I want you to understand that sometimes not just knowing equations and expressions is enough. Sometimes you have to be able to read words and comprehend what they're asking. I'm gonna give y'all 2 minutes to copy this one down because it's only one sentence or 2 sentences. 2 minutes for this one. No, then I'll work it out. So the problem says, or I'll read it once, I'll give you a time to write it first. So the expression 5 over f minus 32 over 9 can be used to write degrees Fahrenheit f as degrees Celsius. Find the value of this expression for when f equals 86. So now it's the same thing we've been doing, but now they gave it kind of a story, right? Now it's converting temperatures. They wanted to find the value of the expression for when f is 86. So then we're going to find the degree Celsius for that. So that we're going to have 5 parentheses 86 minus 32 over 9. And then we use algebra to simplify. PEMDAS, right? Do the parentheses first. It'll be 5 parentheses 86 minus 32 is 54 over 9. Multiply.
I got 30.
You got 30. 5 times 54, I believe, is 270 over 9, which I believe does simplify to 30. So if you were managed to get 30 on your own, guys, good job. Were there any questions on the process or anything at all?
I do have one question though.
Go ahead, sir.
Sometimes I've seen, like sometimes whenever I've done algebra, for example, or Google videos just to like on my own time, just to be clear. And sometimes I've seen some videos say they would go right to left, but correct me if I'm wrong. That never happens. And if it does, it's very rare.
Right to left. If you ever come across a video that you're curious if they're correct, Justin, feel free to forward it to me. Say, hey,
Okay,
this
sure.
video was kind of confusing. Are they on point? I'm trying to, and I'll let you know. Yeah, it's a good video. It's correct, and I'll answer any confusion you have. Okay.
Hey, that means a lot. Thank you.
Yeah, of course. All right. Let's go ahead and move on. There's no practice problems for example 5, just because it was pretty simple. So we're gonna go ahead and move on to a new definition in example 6, guys. Go ahead and give you guys a minute to write the definition and the example 6. So just go ahead and write this down, guys, and I'll go ahead and get started.
So is 6 what we're inserting for X? All right.
All right, let's take a look at this definition, guys. So the definition says a solution is a value for the variable that makes the equation a true statement. So a mathematical statement class can either be true or false. True or false. Let's look at example 6. Determine whether 6 is a solution of the equation 4 parentheses x minus 3 equals 12. Does
I
everyone,
got true.
what did you get?
True.
You got
I
true?
got true too.
All right, you guys, all right. Yeah, I got true. Let me see. Yeah, it is true. Okay, now let me go ahead and quickly work it out. So this isn't about solving, guys, right? So if you solve this, if you distributed and got x by itself and got that it's 6, and that's how you were able to say it was true, that's not what this problem is asking. This problem is asking, can you determine whether this 6 is a solution of this equation here? So what they want you to do is they want you to plug in that 6 for x. That's what they want you to do. And then you want to simplify both sides to see if it gives you a true or false statement. That's what this question is asking for. We haven't solved yet. We're going to be solving equations soon, but and this is true. So that means 6. So write this sentence down. 6 is a solution. Now, if it was false, we would write 6 is not a solution. Everyone okay with that? All right. Yes, it does. PEMDAS does really come in handy, guys. PEMDAS is kind of how you do arithmetic in real life. Now, when people when people post those memes of is it 1, is it 9, you can jump in there. Actually, it's and then show them what's up. All right. Let's go ahead and move on. Were there any questions on the steps and process for example 6? All right. Example 7. We're going to determine which numbers in the set 26, 40, 20 are solutions of the equation 2n minus 30 equals 10. Now, it's not about this question. Remember, it's not about solving. It's about, can you check if it's right or not? Because when we move on to tougher equations in this class or in your other math classes that you take after this one, you're gonna have tough equations, like really challenging equations. And
Sir.
go ahead, Jacob.
Oh, I got 20.
Did you solve it, Jacob, or did you check them out?
I checked them out.
Nice, good. Thank you, Jacob.
You're welcome.
So Jacob was able to determine that 20 was the true solution. Let me quickly show you the work for each one. So this is for the 26 value. So it'll be 2 parentheses 26 parentheses minus 30 equals 10. Always put a question mark on top of the equal sign because we don't know if 26 is a solution. We don't know if the left is going to equal the right. Then do PEMDAS. 2 times 26 is 52 minus 30, which is 22. And 22 does not equal 10. So therefore, 26 is not a solution. And then we're going to check out 40. And then we'll check out 20. So 40 is 2 times 40 minus 30 equals 10, question mark. 2 times 40 is 80 minus 30 equals 10, which is 50 does not equal 10. So we know 40 is not a solution. And then 20, same thing. So it'll be 2 parentheses 20 minus 30 equals 10, question mark. 2 times 20 is 40 minus 30. 40 minus 30 is 10. 10 does equal 10. That's true. So this 20 is a solution. Now the key word for these, I want you to write the word false for the first 2 examples here. because it's not a true statement, right? Thank you, Jacob, for the heads up. All right. Now, does anyone have any questions on the process or what to do if you were to see a question on your homework that said, hey, can you check if these numbers are solutions or not with this equation?
So basically, if it's written like this, for example, and it said the three numbers like that, you'd always insert them and then exactly how you have it written, two parentheses, said number.
That's correct, Justin. Now, what's the difference from a solution and not a solution, Justin?
They have to equal the same.
So which one's that? Is that
Yeah.
solution or no solution?
The not solution is, for example, 26. As you see, you bring it down, and then you got 22 on the left side, but you were really supposed to have 10. And as it shows by 20, both are 10.
There you go.
I know
And-
that's an unconventional way of explaining it, but
No,
that's just a good way to
and
put
that
it.
is how it clicks in your mind, Justin, then that is fine with me, sir. The concept was correct. The explanation, there's no like correct way of explaining things. As long as you understand what you're saying, that's the main thing here.
Good to know.
And make sure that on the equal sign, there's a line through it. This equal sign, whenever you have an equal sign with a line through it, that means not equal to, okay? This line with this equal sign means not equal to. Because you will see this in other math classes, okay? That's a mathematical symbol. All right. Does anyone need more time on this slide before I move on?
I do.
Okay, I'm gonna go ahead and give you guys about 2 minutes. Then we'll move on. Let me know when you're good to go, Jacob, or anyone else, or whoever else is.
I'm good.
Okay. Okay.
All good.
Everyone good? There's a 1 minute left. Anyone need that 1 minute? Last call. Anyone need that extra minute? All right, let's go and move on, guys. All right, go ahead and take a moment. I'm gonna give you about 4 minutes to write this chart that's on the board that has addition, these columns with these words, and example 8. I'm gonna give you about 4 minutes to write the box and example 8. 4 minutes. Please write this chart, guys. This chart will be your best friend this class because you will see that you will have to utilize this chart throughout the whole semester, guys. Can anyone guess what's important about this chart?
What I can gather gives you important keywords.
There you go. Good job, Justin. And they are important keywords that would highlight the operation that the problem will be asking for. So if you see these keywords in a word problem, whether it be in my class or the next math class. All right. Does anyone need more time to copy down the example and the chart before I start working it out? Anyone need more time to copy things down? Because I wouldn't want you to be copying when I'm trying to work it out.
I do.
Okay, I'll give y'all another minute or two. All right. All right. So if you take a look at the chart, guys, the addition words all kind of correlate with addition. So sum, plus, added to, more than, increased by, total. Difference, minus, subtract, less than, decreased by, less is for subtraction. And you can see those words there for multiplication and division. Now let's take a look at example 8. Write as an algebraic expression, use X to represent a number. Use X to represent a number. So letter A. So let's go. I'm gonna go ahead and read A aloud. A says 7 is increased by a number. So look at the chart. Where do you see the keyword from? What column? It's an addition column. So we know 7 is first, right? 7 and is increased by, that's the keyword there. So that's plus. And then a number, we are using X to represent a number. So it's 7 plus X for A. All right, let's take a look at B. 15 is decreased by a number. 15 decreased by a number. So 15 is first, and this is being decreased by, so decreased by is subtraction. By a number, we don't know what that number is, so we're gonna write X for that number. So B is 15 minus X. C is the product of 2 and a number. So we know product implies multiplication. And these two are the things that are going to be multiplied, 2 and a number. So it'll be 2 times X, which is just 2X. Or you can write or 2 parentheses X, or you could write 2 times X, either or. Any of these will be the right answer for C. D, the quotient of a number and 5. So the quotient is division. So of a number and 5. So it's going to be X over 5 or X divided by 5. So the first thing here is going to be the top of the fraction. And then the second part is going to be the bottom of the fraction. Now, E is the trickiest one, class. E is the trickiest one, and I'm going to do my best to explain it. So E is saying 2 subtracted from a number. So it's not saying 2 minus a number. If it said 2 minus a number, it will be 2 minus X, right? But read the English.
X minus 2.
Woo! Yes, Jacob. That is what's up, sir. That is correct. X minus 2. Because we're 2 is being subtracted from a number. So let me give you an example in real life. If I was like, let's say I was your manager, and I whatever job it is, right? And you got new shoes from the job. I'm like, hey, we're gonna subtract $2. 2 is being subtracted from your paycheck. 2 is being subtracted. 2 subtracted from your paycheck. So we're gonna take away 2 from whatever number it is, right? So it'll be X minus 2. So that's a key one. So put a star by the E, guys, a star by the letter E, because this is, you're gonna see this on the test. You're gonna see this on homework, and do not get confused by E. Remember that it's X minus 2, not 2 minus X, okay? All right, and then we have a helpful hint. So go ahead and write this helpful hint on your notebook, guys. Make sure you write helpful hint and write what it says inside the box. And then work on practice 8, guys. I'm gonna give you 5 minutes for this practice problems and the helpful hint. I'm gonna go ahead and get some more water. Give me a second. All right, are there any questions so far, guys? Does anyone want to volunteer and say what they think the answer for A is? Well, look at your chart, Justin. Look at the chart that you have.
I got x times x.
Ah, twice a number. You got X times X. That's a potential one. Okay. So think about when you twice something.
Can you use x squared? for
Two
that?
X.
Ah, so it's either I'm getting either X squared or 2X. Now, mathematically, are these the same thing, class? Is 2X and X squared the same thing? What do y'all guys think? So first ask, where's twice at? Do you see twice anywhere in the chart? Now, twice is a synonym for the word double. Double and twice are synonyms. All right, so go ahead in your chart that you wrote, write the word twice to include twice next to double. Now let's take a look at it. So think about when you twice something. So let's say you normally order 6 donuts for your coworkers, right? You take 6 donuts and your manager's, hey, can you bring twice the amount next time? Because, 6 wasn't enough. When you twice something, what are you doing?
Doubling it.
Doubling it. There you go, Jacob. So let's look back. So which ones do y'all feel more confident with? Y'all think it's X squared or 2X? Which one's doubling? Which expression doubles?
X square.
So, okay, so let's say you remember you said 6 donuts, right? Remember the scenario I gave you 6 donuts and I told you to bring twice amount. What's 6 squared? 6 squared is 36. Is
It's
that
2x.
is that double the amount of donuts? No, right?
No.
But so it's 2x. There you go. Does everyone understand why it's 2x over x squared?
Yes.
Is it because of the fact that 2 represents twice?
There you go. Twice represents 2. All right. All right. All right. I appreciate y'all's thoughts. You notice how we had a discussion, how we went back and forth with everyone's thoughts until we all came down to the same place. That is how math works, class. Let's look at B. Any volunteers want to share what they got with B?
8 plus X.
8 plus X. Does anyone agree or disagree with 8 plus X? Good. Justin
agree.
agrees. Sophia agrees. Excellent, class. Excellent. So these are both right. A and B are correct. Let's look at C. Anyone want to take a chance at C?
Got 10 minus X.
And minus X. Does anyone agree or disagree with Justin's answer? No? Did y'all get stuck on C, guys? 10 minus X? 10 minus a number?
Agree.
I
I
agree.
agree.
Good, good, good. Because I remember, I know how to do this. This is for you guys to practice it. D. Anyone want to try D out for me? Share what they got for D.
X minus 10.
X minus 10. Does anyone agree or disagree with X minus 10?
I
Agree.
agree.
Good job, guys. Good job. Good job. E. Any volunteers for E?
Well, I got 2, so either one could be right or wrong. One of the options I thought of was 6 over X or X over 6.
Oh, those are 2 different answers. So what do you guys think with Justin's options? Anyone agree, disagree with one of them over the other?
I agree with the first one. 6.
Over
The
X.
first one.
The first one. Because remember, when you see the word quotient, the first thing is the top, and whatever is second is going to be the bottom part of the fraction. Okay, Justin? So,
Yeah. Okay.
all right, good job. All right. Good job, class. And we officially finished the first section of today, guys. Wow. Was that a good pace for everyone, or do y'all feel like I rushed y'all? Like, how do y'all feel about it?
A little rushed, tiny
All
bit.
right. All right.
Well,
Um,
I
In
feel
between,
I
but I
feel
feel
good
like I'm,
afterwards.
oh, sorry.
Now you're good. You can go.
The lesson was smooth. It was
Okay.
good.
Yeah.
Yeah,
It
if-
was.
Never have
It's
caught
just a
on this
regular.
much.
Yeah, if y'all need more time, like Ishmael, like if you say, like, if you know, like you feel rushed, say, hey, sir, can you slow down? You can even chat me personally, but hey, sir, can you slow down a little bit? Or hey, sir, can you repeat? I do not mind, all right? Like, I'm one of those professors that listens to what y'all think, because I'm here for you guys. Like, I know math already. Like, I'm a mathematician. I'm here to help you guys build your math skills. So if you feel like I can slow down a little bit, just let me know, sometimes you can tell when I teach math, I kind of get excited and I kind of mumble sometimes, and my apologies. So, all right, cool, cool,
I
cool.
don't feel bad. That's how I am with reading history in the political system.
Ah, okay, interesting. Okay, okay.
Like you said, whenever I asked you that question of what got you into math, we all have that thing we're interested in. And in your case, it happens to be math.
That is correct. All right, guys. So we're gonna go ahead and get started with 2.5 today, but I do want to give everyone a break. So I'm gonna give everyone a 5-minute break. Go ahead and stretch your legs, give your hands a little rest, go get some water, use the restroom. And once the 5-minute timer, oh, actually, let me take attendance before I start the time. Let me do attendance before I start the break. All right, remember, guys, to say here if you're here. Give me a second. Attendance. And you can put it in the chat that you're here. You can unmute and say here. Jacob Cox.
I'm here.
Excellent. Aaliyah. Aaliyah Cuevas. Excellent. Marisa. Is Marisa Cuevas here? I see you in the chat, Marisa. Are you there, ma'am? Marisa. Okay, there you go. Awesome, awesome. Alexis. Alexis Esquivel.
Yeah.
Okay. Brandon.
Here.
Felicia.
Here.
Jose.
Here.
Wanda.
Here.
Ana Lucia. Ana Lucia Martinez. Last call for Ana Lucia. Jacob Martinez.
Here.
Jolene.
Here.
Good. Christian.
Here.
Diego. Ishmael.
Yes, sir.
Sophia.
Here.
Marleth. And then Shirley texted me. Justin.
Present.
Awesome. All right. So the only ones that I don't have here is, and then Ana Lucia, are you there, ma'am? Or maybe she left because I said about the break, right?
Oh yeah, I'm here. I'm sorry.
Okay, yeah. No, you're good. I was just like, I know I just announced a break, and then here I am doing attendance. So I got you, Ana Lucia. Thank you.
Thank you.
No, thank you. All right, guys, so your 5-minute timer for breaks. Oh crap, I'm recording. Ugh, damn it. So yes, we've seen these steps already in 1.7, but this section is purely on order of operations. But now the numbers and problems we're gonna see in this section are gonna be a little more intense than the last section, okay? The main difference is there's now gonna be negative numbers involved. Now, before we move on, one of the things I want you to include now in your notebook, somewhere on to the side, is I want you to write that a positive times a positive would always be a positive. Now, this plus sign means positive number, right? This positive number times another positive number will always be positive. A positive number times a negative number will always be negative. A negative times a positive will always be negative. And then it happens to be when we do two negatives, it becomes a positive. And this little reference chart will be a key to you. Now, some people get confused on this part. Like a student yesterday was like, "Sir, your box confused me." I was like, "What?" I didn't understand the symbols, so I felt kind of bad. That's why I'm kind of explaining the symbols. These symbols represent what kind of number it is. So positive plus is positive numbers, minus is a negative number. Does everyone understand how this box works now? Like this is saying that two positive is always gonna be a positive, and so on.
Is it Nacho Man?
What'd you say?
Nacho Man, 2 minuses and a plus. That's what I
Two,
usually do.
two negatives, yeah, make a positive, yeah. So then this is pretty much for multiplying and dividing numbers, integers, and dividing integers. Now an integer is pretty much a negative or positive whole number, no decimals. All right, let's look at number 1. So this example, they want us to find the value of each expression. So number 1 wants -3 squared, which is equal to a -3. Like remember, exponent is repeated what? Multiplication. So what's being repeated here? What's in parentheses? Well, -3. So we're going to multiply a -3 times another -3. And using this chart here, what's the product going to be? What's the answer of -3 times -3?
Positive.
A positive. There you go. A +9. That is correct. Now you don't ever have to write +9 like a positive symbol. The only one you have to write is negative. Now number 2 is different, right? Because this one is saying that 3 is being squared, not -3, just the 3. So this one is saying it's going to be -3 times 3. So 3 times 3 is 9. Here is an invisible -1, right? Well, 9 times -1 is a -9. Problem example 3 is 2 times 5 squared, right? So it's saying it wants us to multiply 2 times 5 times 5. 2 times 5 is 10, times 5 is 50. And we are done. Now, the key ones I want you to take away from this example is number 1 and 2. With parentheses and without, and you see the difference in the outcome of the product, okay? This is the key ones I want everyone to take away from. Does anyone need more time to copy this slide down before I move on?
I do.
All right, let me know when you're good to go, sir, okay?
Sorry, can you explain how you got 50 again?
Yeah, so the problem was 2 times 5 squared, so it was written like this. Oh, let me write this again. So it was 2.5 squared. And remember, 5 squared is just repeated multiplication, right? And it's what's being repeated, what number?
5.
The 5, right? Not the 2, right? The 5. So that's why I wrote 2 parentheses 5 and 5. And then remember, PEMDAS, we multiply from which way to which way? Left
Left to right.
right. So what I did first, 2 times what?
2 times 5.
Which gives us what, ma'am?
2 times 5, 10.
Good. And now we're gonna do 10 times what now?
5. Oh, that's how you got 50.
There you go. Yeah, good job.
Thank you.
No, anytime. Great question. All right. Any other questions or more time to write, guys?
I'm good.
All right. Thank you, Ishmael, for letting me know. All right, I'm gonna go ahead and give you guys about 3 minutes to copy this helpful in. Please write this helpful in, because this is where a lot of people, I'm gonna be honest, got points off on their homework and tests because they did not remember the difference between a parentheses negative number and not a parentheses number. So I'm gonna go ahead and give you out 3 minutes to write this helpful hint now. All right, does anyone need more time to copy this helpful hint?
I need a little bit.
All right, let me know when you're good to go.
All good here.
I heard that, right? You needed more time, right? Someone did?
Yes, I will. I do.
Okay, just making sure. 'Cause I heard two people and it threw me off. Okay, let me know when you're good.
Okay.
Awesome. Thank you for letting me know. All right, guys, let's go ahead and move on. All right, go ahead and try these practice problems, guys. I'm going to give you about 2 minutes on these practice problems. It's similar to the examples 1, 2, and 3. But now it's a different base and another exponent. So remember, the definition of exponent is repeated multiplication. So good luck. All right, does anyone have an answer for number 1? What do they think number 1 was?
16.
Does anyone agree or disagree with that 16?
Agree.
Agree.
Excellent, excellent, excellent. What about number 2, class?
-16.
Does anyone agree or disagree with the -16?
Agree.
Agree.
Agreed.
Excellent class. What does everyone think about number 3?
108.
Anyone agree or disagree?
108.
Definitely agree.
Excellent class. Very proud of everyone. If you agreed with all these three answers, you are correct. All right. Anyone need me to work these out before we move on? Everyone okay with this?
Well, I do have one question.
Go ahead.
How is 2 negative again? I just need a little explanation.
I got number 1 and number 2.
2, since we got negative 16 on that.
Okay, so number 2 is negative 2 to the 4th. It's pretty much saying that 2 to the 4th is on its own, but the negative will come there as well. So it'll be negative times 2 times 2 times 2 times 2, right? So what
Right.
number's invisible here that we don't see, Justin?
1,
What kind of one?
-1.
And what's a -1 times 2?
-1 times 2. Bear with me because my brain's a little bit fried.
No, you're good.
2
What
or
kind of 2?
+2.
You sure? Look back at the chart.
Oh, yeah. No, I take that back. -2.
And -2. And then we're gonna go ahead and multiply the -2 with this all the way through. So what's a -2 times a 2?
-2 times a 2 is 4.
What kind of 4?
Negative.
Good. And then we're gonna do -4 times 2, which is what?
-8.
And then we're gonna do -8 times 2, which is what?
1 second. -16.
And there you go. And that's the answer we got.
So generally, on the negative exponents, the one's hidden then. Or
So,
negative.
yes, because the parentheses tells us a lot, right? Because number 1, what's being repeated in number 1, Justin?
A -2.
There you go. Here, what's being repeated still for number 2?
4 because that's the exponent.
Well, not the 4, but what number is being represented or repeated? What kind of?
Oh, no, yeah, 2.
There's a positive 2. You see that? You see the difference?
Yeah,
Okay.
cool.
All right. Let's go ahead and move on, guys. All right, I'm gonna give you about 2 minutes to copy the first 2 examples. I'm gonna give you 1 minute to copy example A and B. We're gonna do this slide and then the practice problems for these examples, and then we'll end the class after these 2 slides, okay? And then we'll go ahead and talk about my math lab, how to get access to it. I did send emails out with steps, but I want to make sure everyone can see what I'm talking about. Because you have homework you start doing now. So once I extend the due dates for the other homeworks for 1.7 and stuff, I recommend you to start doing them. All right, let's look at example A. So it's a fraction, so we know how to simplify a fraction, right? We do the top and then the bottom, and then we divide, right? Well, the top is just gonna be -6 times 2, right? So let me bring back the chart that I wrote in the first slide. So a positive times a positive is positive. A negative times a negative is also positive. When it's one and the other.
-12, right?
Yeah, it is -12. That's correct. So then we get a -12 over -3. 2 negatives make a what?
A positive. Oh,
A positive, right? 12 divided by 3 is what, class? How many 3's go into 12?
4.
4. And we're done with number A. Let's look at B. Remember, we're simplifying the top and the bottom. So the top is 12 minus 16, guys. So I like to use money and banks when it comes to adding, subtracting positive and negative number. So look at B. B says 12, right? You have $12 in your account. You spend, because it's minus, you spend 16 at the mall. How much do you go to the bank if you overspend?
Or
What kind of four?
negative or
Excellent. Now over, what's the bottom? -1 plus 3. -1 is you owe the bank $1, but you added $3 into your account. So
+2.
+2. Now we're dividing a -4 and a +2, which results into what quotient? What's the answer?
+2.
Are you sure? It's a
Negative 2.
Yeah.
-2. When the signs are opposite, negative and positive, it's a negative answer.
That's true.
Okay, so let's look at C. Remember, following PEMDAS, there's no fraction now, so we have to do parentheses, there's none. There is exponent, right? Exponent is -2 cubed. So we're repeating multiplying -2 how many times? 3 times. So we're gonna get -2.
8.
What kind of 8?
Positive.
Let's find out. So I wrote -2 3 times, right? What's -2 times -2?
+4.
+4, but we're multiplying that +4 with the what?
It's negative, so it's -8.
There you go. Good catch. So it is gonna simplify to a -8 class. Well, I'll leave it there for you guys to see. So I'm gonna bring down, so the -2 cube becomes a -8. So I'm gonna go ahead and bring down everything else. 60 plus 30 plus -8. Put that in parentheses. Guys, can we add a negative number? Can someone tell me what's the same thing as adding a negative number? In case you didn't know this, when you're adding a negative number, that is the same thing as subtraction. So we're actually doing 60 plus 30 minus 8, okay? So I need you to understand that when you see a plus a negative, that is the same thing as -8. Okay, now we add and subtract from left to right. 60 plus 30 is 90. And then we do 90 minus 8, which is 82, and we are done. What questions do we have with letter C? All right, D is gonna be a pain in the ass, right? Because we have how many exponents do y'all see on letter D?
3 exponents.
3 of them. So let's do the first exponent first. -4 squared. Can someone tell me what they think that will result to? -4 squared.
-16, right?
-16, correct. Can someone tell me what's gonna happen with the second exponent, -3 squared?
+9.
That's correct. And then bring down the minus, right? And then 1 cube. 1 cube is just 1 times 1 times 1, which is always gonna be 1. Did everyone see me simplify the exponents? Any questions on the exponents? All right, now we add and subtract from left to right. -16, guys, you owe the bank $16. All you could deposit was $9. What do you still owe the bank?
-7.
-7. Bring down the -1. You owe them 7, but you just couldn't help yourself to a dollar candy. So now you owe the bank how much?
-$8.
And we are done. What questions do we have on D now with the steps we took? Any questions at all? All right. Anyone need more time to write this slide down before I move on to the practice problems?
I think it really does show, like I mentioned earlier, that how much PEMDAS is really used previously, setting the precedent.
Yeah,
These another fine example.
all right, let's see how y'all do, guys. Here's your, this is the last slide we're doing today, and then we're gonna call it. So let's finish off strong, all right? I'm gonna give y'all 5 minutes to work on these. I'll make it 4 minutes. And I'll add more time if you need it, but good luck. I'm gonna go ahead and use the restroom real quick. All right, I'm back, class. If you have any questions on any of these, feel free to let me know. Or if you want to start saying what y'all think the answers are for certain ones, you can type them in the chat or unmute and I can write them down. Good luck. All right, guys, that was the timer. How's everyone doing so far? Anyone want to share with what they got for number one?
I got 5.
We got a 5 for number one. Does anyone agree or disagree with 5?
Agree.
Agree. We have an agree. Cool, cool, cool. Anyone disagree? Okay, anyone want to share their answer for number two?
3.
Did you say number three?
Yes, sir.
Thank you, thank you. So we have a 3 for number two. Anyone got something different?
I agree with Ishmael.
Good, good, good. Anyone want to share what they got for number three?
$16.
I got 16 too. Yes.
Excellent. Good job, class. Last one. How did y'all do? Anyone figured it out yet?
I got -7.
You got -7?
Yes.
Anyone got something different? Just waiting for other students' feedback for practice problem number 4. Number 4 is the only one I haven't heard agree or disagree with -7 class.
I got a +7.
We got a +7. Ooh, the plot thickens, class. It's a debate. Is it -7 or is it +7? So let's determine that. Let's figure that out, right? Let's break down the exponents for each one, right? Well, 1 to the 5th is the easiest, right? 1 times 1 times 1 times 1 times 1 is just what?
1.
1. So bring down +1. Can someone help me out with -4 squared? What you're gonna do?
16.
What kind of 16? Positive or negative?
I got a
Positive.
positive.
Positive, right? Because what's being repeated?
The -4 itself.
-4, right? And then we know that 2 negatives make a.
Positive.
That's correct. Now on the last one, what do we on the first and last one, -2 cubed? What's being repeated?
Just the 2 cube.
2, right? And then at the end of it is gonna be what kind of number though?
The -1.
There you go. So and what does it result to? A negative what?
-8.
There we go. And now we add and subtract from left to right. So -8, you owe the bank 8, you deposit 16. What do you have now in your account?
$8.
And then you bring down the +1, right? What happens to 8 plus 1?
Oh, 9.
9. All right.
I subtracted 1. I forgot the plus. I subtracted on.
Now you're good, but you see it's a plus, right? You're good now? Does anyone have any questions on the steps that we took, class? Everyone okay with my explanation for each one? How we simplified the exponents, class? Is everyone okay? Excellent. All right. Anyone need more time to write down this slide or anything before I move on? All right. This was the last one, so I'm gonna go ahead and stop recording.